Hello, everyone. Today we are going to be, you can read it at the top, we are going to be solving exponential equations. So it's kind of weird. Up until this point, we have never dealt with how do you go about solving something where the exponent isn't in, it's like down below, it's not in the exponent. We've never actually gone through how to kind of solve these types of problems because obviously we haven't really dealt with any exponential equations, whether it was in algebra 1 or anything up until this point, actually. The variable has always been either the base being raised to the exponent or it hasn't had an exponent at all. So when it comes to solving exponential equations, if you guys look at the top problem, this really isn't more a review of a past day. It's more of a hypothetical question. What value should you plug in for x to make this true? I want you guys to pause your video and see if you can figure out what x should be to make whatever you plug in for x to make that equation true. So pause your video and I want to see if you guys can figure it out. Give it a shot. Well, hopefully your final answer, if you weren't sure, you could have typed this out in your calculator. If I take 2 to the 4th, we get 16. So if your job now, like I said, this isn't always how we're going to solve it because a lot of times with variable exponents, this won't be present. But you want to ask yourself the question, well, what do I raise 2 to get 16? Well, 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. And 2 to the fourth actually ends up being 16, which means our answer to this would be x equals 4. So when you're solving for the exponent, there is an easier way to do this. And that is when you look at this and you see those bases are the same, what we do is we just set the exponents together. We set them equal to each other because if your bases are the same, then really the equation that we're looking at is what's going to make the exponents the same. So all we do is we set them equal to each other. So that right there is kind of the base for how we solve exponential equations in general. So our goal when it comes to solving exponential equations, they all kind of have the same process. We want to get the base of each side of the equation. So the number being raised to the power, we want to get them to be the same. Because then what we can do is we can set the exponents equal to each other. So like if you look down at example number 1, sometimes it's not as easy to tell right off the bat because my bases right now, 2 and 8, they're not the same base. So the question is how can we rewrite either the first base or the second base to end up being a base of 2? So like I asked myself the question, well, is 2 to some power actually equal to 8? And the answer to that question is yeah. If I rewrite 8 as 2 to the third power, that is, now you have the same base. Now it might help to kind of simplify using our exponent properties, right? When you raise a power to a power, we multiply those exponents together. But here, now we're kind of where we were at in the beginning. 2 to the what equals 2 to the 12th? Well, that just means x has to be equal to 12. Okay. So really rule of thumb with any of these problems, and I'm going to skip around a little bit, is we want to try and make it so that your variables, the exponents, or the base, ends up being the same. Because then we can just set our exponents equal to each other. So like here, a lot of times you want to look at your bases and kind of think like, which base can I rewrite them either both as or one as? This one I don't have to do both because I know that 125 can be rewritten as 5 to some power. Now, if you're not sure, this is where you can go to your handy dandy trusty calculator. If I go 5 to obviously the second, that we know that's not it. Well, let's try some of the other ones. 5 to the third. What do you know? 5 to the third is 125. So that just means I can replace my 125 with 5 to the third. Now, it might help to go through and kind of simplify a little bit before you set your exponents equal to each other. But like here, I'm going to use distributive property. That's going to be 5 to the 3x plus 6. But now that we have the same bases, now exponents we can set equal to each other. And now we can solve. Subtract 3x to the other side, which is 2x equals 6. And last step is going to be to divide by 2. And we get our answer of x equals 3. Now, could you try it out if you really wanted to? Sure, you could plug it back in. If I raise 5 to the 15, right? 5 times 3 is 15. That's going to, and if you'll notice, if I type in 125 raised to the 3 plus 2, which is 5, fun fact, you actually get the same answer. So that is ideally what we're looking to do. So what I want you guys to do on example 4 for today's notes, I want you guys to try example 4 on your own right now. Pause your video and go. Final answer, you should have got x equals 15 over 8. Now, if you didn't get that or kind of got lost, just this one was a little bit tricky because you had to convert both of these numbers to be the same base. So usually rule of thumb, if you try raising the second, like one of the smaller base to give you 16, the problem is though, is if I do 8 to obviously the first, it's not 16. If I go to the second exponent, 8 times 8 is 64, and I skip 16. So this is a case where that means we want to break down 8 into a smaller exponent. And a lot of times a common one ends up being 2. 2 is a common base for actually both of those numbers. If I type in 2 to the third, that's what gives me 8. That's how I got this piece. And 2 raised to the fourth power actually gives me 16. So you want to pick a base that you can rewrite both of the numbers in it by. So once you do that, then that everything is kind of smooth sailing from there. Obviously, here the next step was we distributed our exponents. 4 being raised to the 2x minus 3, we distribute that through, we multiply it together. And then our bases are the same. Then we could just set our exponents equal to each other and solve. And that's how you get x equals 15 over 8. Okay. Now there's one other property that might pop up, and it's like on example 6. Now here you're going to notice, you're like, well, Miss Artie, what do you do with a 1 over something? Well, these are kind of fun in that we don't really like dealing with a base that's a fraction. So a lot of times if we have it written as 1 over something else, remember you can use negative exponents to turn something or move it to the opposite side of the fraction. So instead of being 1 over 32, if I raise it to the negative 1, it turns out to just be a base of 32. And our exponents stay. So if we multiply those exponents together, this becomes 32 to the negative x minus 3. And now this becomes kind of every other problem that we work with. I'm looking for what can I change 32 by? What base can we use that also is the same base as 16? It can't be 16 because if I do 16 and I raise it to the second power, that doesn't give me 32. So that just means 16 and 32, I'm kind of suspicious that 2 is the base. 2 raised to what power? What gives me 16? Well, that's going to be 2 to the fourth power. We already did that one. And what power do I raise 2 by to give me 32? Well, that's going to be 2 to the fifth. And if you didn't know that, again, you could check it out in your calculator. 2 raised to what power? What gives me 32? You could kind of trial and error that and you can figure that out. But if I distribute my exponents, 5 times negative x is going to be negative 5x. 5 times negative 3 is going to be negative 15. And 4 times 3 is going to end up being 12x. Now that your exponents are the same, now we can set them equal to each other and we can solve. Add 5x to the other side. Negative 15 is going to be equal to 17x. And last but not least, we're going to divide by 17. So x equals negative 15 over 17. All right. All right, guys, that's it for today. So if you want to try some of the you try nows, go right ahead. If you want to move on and start working on for the homework today, then that is also something that you can do. All right, pause your video, or you can stop your video now. Not pause your video. Stop it now.